Okay, so number 5 of these says to write force diagrams and force equations for each one of them. So this is obviously the longest problem ever. So for the first one, we'll look at this. It says just by looking at it, the system is accelerating. So there's going to be a net force somewhere. Um, there's also friction in the problem because it says friction is greater than 0 right there. That's the coefficient of friction. So let's look at there's two different systems going on right here. There's that one and that one. So there's going to be two force diagrams. The first one is, I'm going to look at the big 15-pound box. So because it's just sitting there, well, it is just sitting there, so there's always going to be force gravity. If anything's on Earth, there's going to be force gravity. And because it's sitting on a table, let's just say that's a table or whatever, there's going to be force normal working back on it. And because they just assume that there's no pulley system attached to it, it wouldn't be moving. So then those things have to equal out. But obviously there is a pulley thing, so there is some tension pulling it this way. So there's going to be tension going that way, and because there is friction, because it's wanting to go that way, friction is going to make it go that way. So our force diagram is going to look something like that. I made the equality marks for force normal and force gravity, and then there's no force, the force friction and force tension will not be equal because there is an acceleration. So if you want to write the equation for that, we'll get an equation, two different equations, that will say force gravity plus force normal equals 0, while force tension plus force friction equals the net force, or force net. Now let's focus on this one up here, the smaller box. So this equation, or this system, it has gravity working on it, but because it's not attached to anything, there's no force normal. But there is force tension. Because it's accelerating, that means this is causing the box to move, meaning that the gravity is working. So this part is accelerating. So there should be a net force. So the two things that there's two things. There's gravity and there's force tension. That's the only two things. There's no horizontal or vertical. Like this one, we had vertical of force gravity and force normal, while we had force friction and force tension horizontally. This one, we actually have force tension vertically. So our our vertical equation will be force gravity plus force tension equals the net force of that equation, or for that, because both of the systems, the 2 and the 15, are accelerating. So there's going to be a net force. So for this one, I know it has a bunch of writing on it. It is pretty much a box on a hill, and it says the block is motionless. So from there, we know that they have to equal 0, because if it's motionless, there cannot be a net force, because there can't be anything making it go anywhere. So from there we know, I'm going to draw the force diagram, because we know that because it is on Earth, there's going to be gravity, and we know because it is on a surface somewhere, it's going to be force tension, and because the box is going to want to go down there, there has to be something to make it stop, make it stay. So that's why I included force friction there. So here's a better force diagram that kind of is going to explain it. So you're going to kind of be like, oh, why is there a triangle there? Good question. So we have force gravity, like I showed. Then we have force normal, force friction. Force gravity, though, has each one of these has pretty much two different parts, an x and a y. So I had to break up the x and the y in order to show how each part of gravity, each vector of gravity, is equal to one another. So the x, because it's going this way, just like force friction is. I kind of didn't draw this right, but it should be going the same way, or it should be going, I guess, the opposite way. Force gravity, the x version, or the x-axis version, should be going the opposite way of force friction. This makes sense because say force friction is 2, and say this is -2, they balance out, meaning that there's no net force. This one, force of gravity y, is going the opposite way of force normal, which say this was -2, say that was 2, they would equal each other. I mean, if you look at how the directions they are going, they're the same way. I mean, this one should be tilted a little more like that, but I mean they're what it should be. So when you break down these vectors or down these two different things into two different vectors, you see how they're related. So we can get an equation from that. We can look at this first one. We can look at the x way. So we can say that force gravity x plus force friction is equal to 0. And then the y, force gravity y plus force normal is equal to 0. So pretty much what I'm saying is this plus this equals 0, and this plus this equals 0. Because this force gravity y and force gravity x is the same thing as force gravity. It's just the two different parts of it. So that is a way that three things can really add into making it 0. So for the last part, we have that guy. So it's a box laying on a surface that's getting pulled. So the box, because it's on it's on Earth, will be the force normal and the force gravity will be equal to 0. They will be balancing out. So whatever force tension is going to be pretty much your net force. But you have to look at the different vectors of force tension. You can see that force tension can be broken up into force tension y and force tension x. But it has a y component of it. So that means that this force y is going up and this one is going down. So each one of these is equal to, when added together, is equal to 0. So it's force normal plus force tension y is equal to, say, 2. Okay, so that's 1, that's 1. And then force gravity is equal to -2. So that's going to be equal to 0. But because there's still force tension x, that means that the net force is going to be equal to whatever force tension x is. So force normal, I'll just recap. Force normal plus force tension y plus force gravity is equal to 0. And the only thing that's left is your force tension x, which will be your net force. So I'll write the equation out right here real quick. Force normal plus force gravity plus force tension is equal to 0, while force tension x, the x coordinate, is equal to the net force. So just a little brief overview of everything that we did here. Zeros are motionless, and then our little force diagram for part 2.